Yeah, understanding standard deviation, where it comes from and why it's used. This is something that I see students struggle with. So let's go through this today. Save this video for later in case you need it. And of course, if you're a parent, save it for your child, right? So let's go for an example. Let's say we've got some numbers, some data, and let's try and calculate how spread out they are, right? Let's try and find a way of calculating how spread out these numbers are on average. That's the whole idea. So what we're going to do is calculate the mean of our data and calculate the differences between the data values and the mean, right? So let's just see where that leads us, okay? So let's calculate the mean of our data. So on average, the average mean value is 8.8 if we calculate that. And now let's calculate the differences between our data values and that mean, right? So take all of your data values and do that value, take away the mean 8.8 and list out those numbers. So we've got all of our differences there. So we've got our differences for each of our data points. Now let's try and calculate the average difference, okay? So let's try and calculate the mean of all of those differences and see what we get. So add up all of your differences, including the minus signs, right? Take the average, divide by five numbers, and we get 0. Oops, that's a bit of an issue. So the whole idea is that if you do that, the minus signs will cancel out the positive differences, right? So that doesn't work. The trick is to square them. So you actually want to square all of these differences. So you take those differences and you square them. So now you calculate the average of these square numbers, right? So you square them, you add them all up and you calculate the average of those square values. And if you do that, you should get about 15.36. So we call that number the variance. So that term is the variance. That is the variance of a data set. So when you follow that calculation for any data set, you call that number, you get the variance. So then if you square root it, you get the standard deviation. And the reason you square root it is because we squared all those differences. So it kind of makes sense to square root our final answer to get the standard deviation. So 3.92 to 36 figs would be our standard deviation. Now let's try and put this all into an algebraic formula, a nice algebraic formula. So we know the variance is this, right? So we've taken all of our x values, right? So x1 is our first data value, x2 is our second data value, x3, so on and so on. And we're finding the differences between those data values and the mean, x bar. So x bar is the mean. We're taking the differences, we're squaring them, adding them all up, and we're dividing them by n, right? So that's exactly what we did on our calculation. Calculate the differences, square them, add them up, divide by n. So we can use sigma notation, right, to make it look nice and neat. So from I equals 1 up to n, the sum of all those differences squared. And then when you square root it, you get the standard deviation, right? Now, just a little note, if you are an OCR MEI student, use n minus 1 instead of n. The reason for that is a bit technical, but for most examples, use n, okay? Just so I mentioned that.